Hello, welcome back to our channel. Now we are going to discuss about the expansion of the liquids. What is the shape of the liquid means we can't say that because there is no particular shape and dimension for that, but we can observe that liquid is occupying the container shape. So there is no linear expansion, there is no aerial expansion. We can observe only one type of expansion in the case of liquids, that too when we are providing the temperature, that is called the volume expansion. But volume expansion also we are taking in two different ways. One is the apparent expansion, another one is the real expansion. Apparent means along with container, we are taking the liquid inside the container and we should consider both container expansion along with liquid, that is called the apparent expansion. If we can take only real change in volume of that liquid, that is called the real expansion. Then come to this point here. Here coefficient of apparent expansion means what we are taking, it is represented by gamma A. This is the gamma A. So gamma A equals to same gamma A equals to change in apparent volume of the liquid to the original volume of that one into change in temperature. It should be right Vt minus V naught by V naught into change in temperature. So Vt is the apparent volume at T degree centigrade and V naught is the apparent volume at 0 degree centigrade. Here delta T is the change in temperature. Suppose we are taking V1 is the volume at T1 degree centigrade, V2 is the volume at T2 degree centigrade. In this case gamma equals to A means apparent expansion, we can take it V2 minus V1 by V1 T2 minus V2 T1. The unit is the per degree centigrade or per degree Kelvin also we can able to take it. Then what is the coefficient of real expansion? Coefficient of real expansion is represented by gamma R. Means we can take it only real expansion. Suppose we are taking one container, we are taking some liquid here. We are providing the temperature here. Then what happens? Liquid is expelled from this. So in this case, how to write this one? Gamma R equals to same V2 minus V1 by V1 T2 minus V2 T1 or gamma R equals to Vt minus V naught by V naught into change in temperature, you can take it. So here what is, here also we took the volume change and here also we took the volume change, but you should remember that in this case this is the real change in volume and this is the apparent change in volume. So this is the difference between these two. Now what is the relation between them? Relation between gamma A and gamma R equals to very important formula. Gamma R equals to gamma A plus gamma G. So this is the real expansion, this is the apparent expansion and this is the glass. Mostly the containers are making with glass only. Otherwise instead of G we can take it the C also. But this is belongs to solid means we can write it gamma R equals to gamma A plus 3 alpha G also we are writing. Suppose gamma A equals to 0.00003 per degree centigrade and alpha is the 0.0006 0.00, how many zeros? Here 4 zeros and here also 4 zeros per degree centigrade. Find the gamma R means what we are taking, it should be right. Real expansion 3 into 10 power minus 5. This is the apparent expansion plus 3 times of this linear expansion. You know that linear and volume, what is the expansion, what is the relation? Volume expansion equals to 3 times of that that linear expansion. So 3 into this one means we are getting 0.00018 we are getting. After simplification, it should be right gamma R equals to 3 into 10 to the power of minus 5 plus 1.8 into 10 to the power of minus 5. After simplification, we are getting this. This is the 4.8. Gamma R equals to 4.8 into 10 power minus 5 per degree centigrade. So this is the relation between real expansion and volume expansion. Now we are going to discuss about one experiment is there in intermediate, that is the find the apparent expansion of the given liquid. So we can take any liquid, coconut oil we can take it, water we can take it, any other object, any other liquid we are taking, but with the help of that we can able to find out the apparent expansion. But the formula is expelled liquid by remaining liquid into change in temperature. Look, M1 is the mass of the container, empty container. Then M2 is the mass of the container plus liquid, both we are taking. Then M2 minus M1 is the only mass of the liquid. Then after providing the heat energy, all these we are providing at T1 degree centigrade. Then here when we are providing the heat energy, it is expelled out. Some quantity of the liquid is expelled out. At particular temperature, there is no expansion from that. At that time, we can consider the temperature. We can take one more reading, M3. M3 is the remaining liquid plus container. Then M3 minus M1 is giving the expelled liquid. So then how to write this expression here? Gamma equals to M2 minus M3. This is the expelled liquid by remaining liquid. So here M2 minus M1 is the remaining expelled liquid. M3 minus M1 is the remaining liquid into changing temperature. Otherwise you can take one more formula, that is mass of the liquid. We consider mass of the liquid is M. Expelled liquid we are taking X. Then how to write this expression? M by original mass of the liquid is the M. Expelled remaining liquid is how much? How to find out? Expelled liquid is clearly we know that means original mass minus this expelled is the remaining liquid into change in temperature. We do one problem also. If M equals to like 4 grams, then X equals to 1 gram. Then change in temperature equals to 30 degrees centigrade. Then how to find out the apparent expansion of that particular liquid? Gamma A equals to M by M value we are taking 4 by M minus X is how much? 3 into that is the 30. After simplification, 4 by 90, it should be right 0.44 into 10 power minus 1. So this is 44 into 10 power minus 3 per degree centigrade. So when you know the real expansion, apparent expansion and this volume container expansion, we can be able to find out any value. So you remember that this is about the expansion of the liquid. Now we are going to discuss about expansion of gases. When we are going through the solids, we observed that expansion in 3 dimensions along the lengthwise, area wise and volume wise. That's why there are 3 types of expansions are there. In liquids, only volume expansion is there. In that volume, real expansion is called the real coefficient of expansion. Another one is the apparent coefficient of expansion. When we are going through the gases, there is no particular shape. Even these are not occupying the container shape also. But we know that gas also will expand when we provide the temperature. So in this, we can measure that expansion. There are 2 ways. One is the volume expansion. When we are doing the volume expansion, which is constant, pressure is constant. We must take pressure is constant. See how to express this value. We can take it alpha equals to V2 minus V1 by V1 T2 minus V2 T1. Same unit per degree centigrade or per degree Kelvin. V1 is the volume at T1 degree centigrade. V2 is the volume at T2 degree centigrade. But you must remember here, when we are expressing this expansion in terms of the volume, pressure must be constant. Like that, one more expansion is there, pressure expansion. Means that expansion we should express either in terms of volume or in terms of pressure. At this same time, we can't find out both volume expansion and pressure expansion. In terms of pressure expansion, so it is represented by beta. So here volume must be constant. In this volume must be constant, we can write it beta equals to P2 minus P1 by P1 T2 minus P2 T1. This unit also what? This is also per degree centigrade or per degree Kelvin we are taking. Then we are going to discuss about gas laws. What are the gas laws? First one is the Boyle's law. Second one is the Charles first law and second law. From that you are getting the ideal gas equation. Look here. Gas law, first one is the Boyle's law. In that Boyle's law, compulsory you should remember, in gas laws we can use the absolute temperature only. Even the value of temperature is in terms of centigrade, we must convert into absolute temperature, then only we can get the correct answer. See, at constant temperature, pressure is inversely proportional to volume. We can write it P1 V1 equals to P2 V2. Here when we are drawing this pressure and volume, we can get rectangular hyperbola we are getting, because both are inversely proportional to each other. Then second one is the Charles first law. In this, pressure is constant. So volume is directly proportional to absolute temperature. We should write it V1 by V2 equals to T1 by T2. The graph between these two is, this is the temperature and this is the volume in straight line passing through the origin. Or it should be right like this also, straight line. When we are taking 1 by V on x-axis, it is also straight line. Okay. Then Charles second law means here which is constant, volume is constant. In this volume is constant. Here pressure is directly proportional to absolute temperature. When pressure is increases, temperature is also increases. So based on that we can write this expression P1 by P2 equals to T1 by T2. Here also we are getting the graph. Temperature is on x-axis and pressure is on y-axis. It is passing through the straight line, passing through the origin. Then we are going through the ideal gas equation. What is the ideal gas equation? See, at normal temperatures and pressure, we won't expect any ideal gas, but at low pressures and high temperatures, all gases are behaving like an ideal gas or real gas. Anyway, you remember that this ideal gas equation formula is, PV equals to nRT. When we are taking in terms of moles, you are taking, this is the PV equals to nRT. R is the universal gas constant. T is the absolute temperature, like that. Otherwise we can take it PV equals to mRT also we are taking. So this small r is the specific gas constant and this is the universal gas constant. This R value is 8.314 joule per kg degree Kelvin, and this one small r is the, that is we are expressing, that is in terms of mass we are taking, mass of the gas we are taking in terms of grams, like that. Here R we can take it approximately 2 calories per gram degree centigrade also we are taking. So this is about the expansion of gases. Then next video, one more thing it will take, because thermal properties of matter is the very big chapter. So part 1 I have given expansion of solids, part 2 is the expansion of liquids and gases, and one more is the calorimetry we are discussing. Thank you everyone. Please subscribe my channel.